Hi, I think we're back. The audio's on. Yes. I notice I can even notice that with my little microphone here. We are going to get back to our original question from first segment. And that is to draw all the isomers of C7H16. And now that we know how to do stick figures, we can redraw that first one we did with stick figures. No, that wasn't our first one. First one was just zigzags. 4, 6, 7. Now, this is a very popular question for test 1 and sometimes shows up on test 2. And it helps if you have a strategy for this kind of question, because there's no, students are always looking for formulas that can say, oh, I can predict how many isomers there are. Well, I'll tell you, there is no formula. And if you did a graph of the number of carbons to the number of isomers, saying you had like 1 here, 1 carbon, isomers here, and there's only 1 for 1 and there's only 1 for 2, but after that you're getting into the millions here because of the nature of carbon. Oh, there was a big beep in my ear because I have my email open. I hope you didn't hear the beep. So we don't need big graphs, we just need to draw them. And my strategy is to draw the one with a straight chain of carbons. Draw that first, and then after you've drawn all isomers that can be with that chain of carbons, then move on to a 6 carbon chain and move one of the carbons inwards. So let's do 6, 2, 4, 6, and you can move it in here. And on the right side of the screen, you won't lose points for doing these, but you're not going to get points either because they're not unique. So say you drew the first one like this instead. That's just terrible. Try that again. And we'll number these. This is the same as number 1. Not unique here. You do 6 in a row, and off the second last one on the right, you put that. No, that's not unique. You're not going to get points. It's the same as number 2. I'm not big on penalizing people for doing the same thing twice, especially when you're on a timed exam. We don't have time to see if we drew something twice by mistake. That's a 2. All right. Now, you didn't have to move it from the end to the next one in. You could have moved it to the next one in. I hope that made sense. So 6 in a row, once again, 2, 4, 6. There's that 7th carbon there. And we'll call that number 3. And let's do it on this one. Let's say you counted 3rd carbon in from the right side. 1, 2, 3. And that's not going to get points because that's the same as number 3. And when we learn nomenclature next week, you're going to see that following the rules of nomenclature, this one gets exactly the same name as this one, so they're the same molecule. Similarly for this one and this one and this one. Okay, so I think I've explored all the options of moving it from the end of a 7 into the middle of a 6. Now, let's look at all the options. Let's put like little yellow boxes around the groupings here so you can see the strategy we're using here. There we go. So those got grouped together. This is my first one. Let's do 5 in a row. 2, 4, 5. And we can go like this for 6 and 7. 6, 7, both on the same carbon. Let's make sure you know that's the same carbon. Make a dot there. Okay. And we'll call that number 4. And don't pretend that this one's unique. That's the same as number 4. Now those 2 extra carbons didn't have to be on the same carbon. They could have been on second one in, third one in. I'm not going to do every not unique one, guys. I think you've got the idea on not unique. That would be the same as drawing it here and then there, right? And how about 5 in a row again? Second one from this end, second one from this end. That's different. This molecule doesn't have a CH2 in the middle like this one does. Is that the only way to do 5 in a row with 2 sticking off of the chain? We can do 5 in a row and do 2 sticking off the middle. Oh, they can be 2 in a row. Interesting. So these are all a group now. 5 in a row with the other 2 carbons added in. How many ways can you do that? I think we covered them all. We can do 4 in a row with 3 extra carbons sticking off. Not a lot of ways to do that. We could do let's try this. Both on one there and one there. Does that fit the bill? 7? Let's see. 1, 2, 3, 4, 5, 6, 7. It does. We'll call that number 5. Oh, let's be consistent. That was 5. This was 6. 7. Oh, that's the same exact drawing. You know I wanted to flip it horizontal, didn't I? So 4 in a row. Put them both over here. And then a single there. That's number 8. Now I'm going to draw one that's not unique. I'm going to put it over here, and you tell me what number it's the same as. I'm going to try to follow what my strategy was. Do 4 in a row. And then just like I did here, off of one of the ones in the middle, I'm going to put 2 more in a row. And then on this carbon, I'll go there. Which one's that the same as? 5 in a row. You know, that's unique. It should have been up in this box. What am I saying? When you did that, you didn't have 4 in a row anymore. Get used to finding the longest possible chain of connected carbons without lifting your pen. This is not the longest you can go. 1, 2, 3, 4. You can go 5 here. 1, 2, 3, 4, 5. And that's a double branch there. Now, I should have thought of that up here. Let's pretend I did. The instructor will never know on the test. Oh, come on. 5 in a row with 2 off the third one. I think that's unique in that box up there. And I guess I'll just call that number 9. My apologies, they're not in order. And that makes this equal to number 9. Why are they the same? Well, let's do it this way. 1, 2, 3, 4, 5 in a row. 1, 2, 3, 4, 5 in a row. Off the third one in, 1, 2, 3, there's a CH3 and then another CH3. Off the third one in, there's a CH3 and another CH3. They are identical. Okay, by drawing this here, you didn't just put a carbon off there, you lengthened the chain as well, didn't you? And I think we have them all. If you do 3 in a row, I think you run out of real estate to get to 7 carbons. There's no way to do 3 in a row without expanding past 3 in a row is what I'm saying. There's 3 in a row. You only get up to 5 here. Can't put any more on that chain. You got to start adding to the ends to get to 7. I don't know. Let's do this and this. Is that 7? What's that the same as? 1, 2, 3, 4, 5, 6, 7. That's the same as this one again, and this one. Okay, so I think we're going to keep this segment nice and short. That's a good one. Draw all possible isomers. We'll pick up with a different version of this question, having an atom other than carbon and hydrogen in it. And we'll call that our first day. And then I'll work on getting videos uploaded and get you a list of videos. There are hundreds of videos available to you that you might not know about yet. All generated by me, so they're made for you. So we're gonna cut this one short, and I'll see you in about 5.